How many of the four-digit numbers found in part 1 are greater than 6,000?
So would it be 1p1 into 5p3?
1p1 is 1 into 5p3. Why 5p3?
One because there are 5 remaining if you keep the first one as 6, and then there are 3
Yes. If you want a number to be greater than 6,000, it has only one option to start with 6. So one choice. And out of the remaining 5 digits, I just need to select and arrange 3. So 5p3. Either you can write 5p3, or as I've told you, you can write 5c3 into 3 factorial. Okay? It's
Okay.
the same thing. So
Oh,
5p3. Yeah. So 1 into 5p3, 5p3 comes out to be
60.
60. Right. The other method could have been that 1, 2, 3, 4. If 6 is the starting digit, then out of the remaining 5 digits, any of the 5 digits can come at this position times any of the 4 digits times any of the 3 digits.
Okay.
This is still going to give you the same answer. It's just a different method. Do you remember this method?
Yeah, yes, I remember.
Okay. How many of the four-digit numbers found in part 1 are greater than 6,000 and are odd? Greater than 6,000 and are odd.
So
It
it's
has to
gonna be,
start with 6, no options, only one option.
yeah,
And for it to be an odd, it can either end at 1 or 3 or 5. So
yeah.
for the last position, we have how many options?
So it's 3 options, so
Three
3p1.
options for the last. Yes, 3p1. Okay. Then we have picked up 2 digits
Yeah.
and we are left with 4 digits.
Yeah.
Out of 4, I just need
2.
4p2. Okay.
Yeah.
So what is 4p2 into 3?
Uh, 36.
36. All right. Let's move on to part B. A quest team of 10 players is to be chosen from a class of 8 boys and 12 girls. Find the number of different teams that can be chosen if the team has to have equal number of girls and boys.
So will it be 8c5 into 12c5?
So a quest team has 10 players is to be chosen from a class of 8 boys. So we need 10 people. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The
Yeah.
question says that the team should be chosen in such a way that it has equal number of girls and boys. Meaning we want 5 girls and 5 boys, right?
Yeah.
So out of the 8 boys, I'm going to select 5 boys, and out of the 12 girls, I'm going to select 5
5.
girls.
Yeah. It's coming to 44352.
4, 4, 3, 5, 2. Fine. Then find the number of different teams that can be chosen if the team has to include the youngest and the oldest boy and the youngest and the oldest girl.
Would the last part be 2c2 into 2c2 into 16c6?
What is the final answer for me?
I'll just check. 8008.
Yes, that's correct. 8008.
Okay.
So, what was your working, by the way?
I did for two boys, I did 2P2, then for the two girls, 2P2, and then since there's 16 people remaining and six spots, so sorry, 2C2, 2C2, and then 16C6.
Yeah, that's good. Okay, you can try on this question.
Is it 48?
Let's see. How many even numbers less than 500 can be formed using the digits 1, 2, 3, 4, and 5? Each digit must only be used once. So basically, we want a number that is less than 500, and then it can either be a one digit number, it can be a two digit number, or it can be a three digit number. Okay, so
Okay,
if it's a one digit number, then it can be anything like 1, 2, 3, 4, 5. Out of 5 you can have any one number, so there are 5 digits. If it's a two digit number, acha, we wanted an even number as well.
yeah.
Hold on. So even number as well. So how many even numbers are there? Two.
Yeah.
The 2C1, that is 2. If you want a two digit number that is an even number as well and less than 500, so the first in the first position we can have
Uh,
any number
of,
out of these four.
yeah.
So 4C1, and for the last, let's say I place in, okay, I will have to make cases for it.
Sir,
Yes,
in a question like this, how do you tell if it's supposed to be like a combination or permutation?
digits questions are always permutation. So,
Okay.
yeah, you are right. So if I write 2C1 into 1 factorial, this is same as saying 2P1, which is
Oh,
2.
okay. Oh, okay.
If it has to be a two digit number, that needs to be an even number. So I'm going to make cases over here. Two digit number ending with 2 ends at 2. It can either end at 2 or it can either end at 4.
Sir, but isn't it a three-digit number?
I want a number to be less than 500. I want an even number that is
Yeah.
less than 500. So it can even be a one digit number, two digit number, or a three digit number, not more than three digit number.
Oh, okay.
So the two possibilities are that it could either end at 2. If it is ending at 2 and it cannot start at 5, then out of the three options, I'm only going to have, I'm only going to choose one and arrange them in 1 factorial. Or you can just write 3p1,
Okay.
3p1. Now, if it is ending at 4, and it cannot start with 5 again. 3p1. So what is 3p1?
That's
3.
3. Yeah.
So 3, 3. Now let's move on to a 3-digit number, 3-digit even number. If it's a 3-digit even number, obviously it cannot start with 5. And for this last position, either I can have 2 or 4.
Yeah.
So 2c1, okay.
Okay.
And let's say I place in 2, so 2 gone. Then it cannot start with 5. So for the first position, I will have 1, 2, 3, 3 options.
Yeah.
I will have 3 options. And for the next, let's say uh, if I have 3 options, then I place in 3. So for the next position, I can have 3 options. I can have 5 as well.
Okay.
So 1, 4 and 5 कोई भी एक number आ सकता है यहाँ पे.
Okay.
Okay.
Yeah.
So 9 times 2 is 18.
Yeah.
So 18 plus 6 plus 2,
26.
number of ways equals to 20. Is it coming out 26?
Yeah.
Just let's just confirm once more. One digit number, that is an even number. So it can either be 2 or 4, so 2 options. Two digit number, that is an even number and less than 500. Oh, okay, okay. Sorry, my bad. यहाँ पर मैंने एक छोटी सी गलती की है. If I am saying that the 2-digit number ends at 2,
Yeah.
so 2 gone. Out of these 1, 2, 3, 4, any number can come up. Even if the first position is 52, if the number is 52, it is less than 500,
Yeah. Yeah.
right? So
Yeah.
1, 2, 3, 4. So I have 4 options. Either I can write 4c1 or 4p1 or 4.
Okay.
If it ends at 4, again I have 4 options. So 18 plus 4 plus 4 plus 2, 28 ways. That's the
Okay.
answer.
Okay.
ठीक है, क्लियर है ये?
Yeah. Sure.
Okay, try this one now.
Okay.
A committee of 8 people is to be chosen from 7 men and 5 women. Find the number of different teams that could be selected if the committee contains at least 3 men and at least 3 women. So I can have a combination possibility of 3 men,
and 5 women.
4 women, sorry, 5 women. 3 men, 5 women,
Yeah.
4 men, four
For
women, 5 men, 3 women.
three.
That's it.
Um.
Are there any
Yeah.
other possibilities?
No, that's it.
That's it. Okay. So 7c3 into 5c5 plus 7c4 into 5c4 plus 7c5 into 5c3. This is going to be the answer for 1. कितना आंसर आ रहा है?
Understood. Or is it 420?
420. Okay.
Okay.
The oldest man or the oldest woman, but not both, must be included in the committee. The oldest man or the oldest woman, but not both. So the committee needs 8 people: 1, 2, 3, 4, 5, 6, 7, 8. So if I have the oldest man on, if I've selected oldest man,
Yeah.
then oldest women cannot be there.
Okay. So would one be 1C1 into 11C7?
11C, 1C1, yes, and 11C,
11C7.
11C7. It's just a question and combination, yes. Then if I select oldest women, then
It would be the same again, right?
it is going to be the same again. So 11C7 into 2. 11C7.
660.
Okay. The oldest man or the oldest woman, but not both, must be included in the committee. Just a second.
Okay.
Oldest man is on the team, on the committee, then there are 11 people left, and out of those 11, I just need to choose 7. And this is going to be the same when oldest woman is on the committee. There isn't any other restriction as well. सही है. So 330 into 2, 660.
Sir, would it be 10C7 since it says that the oldest man can't be in the same team?
Yeah. You are right. You are right. It is going to be 10C7 because we have taken oldest man and we don't want oldest women. So out
Yeah.
of the remaining 10, we are going to choose 7. 120, 120, 240.
Yeah.
I had a feeling we were doing something wrong, but I couldn't figure that out. Yeah, thank you.
Welcome.
All right.
Would the first one be 10C10?
What is 10C10 equal to?
It's coming to 1.
I think it's also going to be arranged. You need to arrange the paintings as well. Order does matter over here.
Uh, so then 10P10?
10P10. Yes, it is going to
Oh,
be 10P10. 3628800.
yeah.
Second part says find the number of different ways the paintings can be displayed if the paintings by each of the artists are kept together. Each of the artists are kept together. So all the paintings, all the five paintings by Picasso need to be together.
Yeah.
Four by Monet are to be together, and one by Turner. So you are going to group them.
Okay.
You have three groups. The three groups can arrange themselves in 3 factorial. They can shuffle themselves in 3 factorial basis, right?
Yeah, yeah.
And then the five paintings of Picasso can arrange in 5 factorial ways within this block. So 5 factorial for the
Oh,
5 Picasso painting, 4 factorial for the 4 Monet painting, and 1 factorial for the 1 Turner painting. So what do we get?
it's coming to 17280.
17280. That's correct. Now part B says a committee of 4 senior students and 2 junior students is to be selected from a group of 6 senior students and 5 junior students. Calculate the number of committees that can be selected.
So it'll be 6C4 into 5C2.
Which is
That is 150.
okay, 150. One of the 6 senior students is the cousin of one of the 5 junior students. Calculate the number of different committees which can be selected if at most one of these cousins is included. There's a senior cousin
Yeah.
who is the cousin to a junior student.
Okay.
So the question says how many different committees can be found? It at most. At most means that maximum one of the cousin is included, not both. So if the senior cousin is selected,
Yeah.
if the senior cousin is selected in the committee, then I have one senior student on board. How many other senior students do I need?
So then you need 5, right?
I want uh, I need four senior students in total. I have selected one cousin senior.
Oh,
So
okay.
I need the remaining three senior cousins.
Yeah.
So how many in total there were senior students?
They were six.
And one cousin is already on the board.
So
So
five C
out of
three.
the remaining five, I need to choose three. Yeah. And for the juniors, I need two junior students, but the cousin of the senior, that is the junior cousin, must not be on the team. So how many juniors are there left now?
So then it's gonna be
Four?
four, right? Yeah.
Yeah. And out of those four, I'm going to select two.
Oh,
So what's 5C2 into 4C2?
six.
Sorry?
It's coming to 60.
60. Okay. Now, if I have the junior cousin on board, then out of the remaining five juniors, one junior is taken. Out of the remaining four juniors, I'm going to select one.
Yeah.
And now the senior cousin cannot be on the team. So out of the group of six senior students, there are going to be five senior students remaining. And out of those five, I'm going to select four.
It's coming to
So what
20.
is this answer coming out?
20.
20?
Yeah.
20. Okay. Is that the only possibility? Or is there any other possibility as well?
I think that's it.
There is one possibility that will not include neither the senior cousin nor the junior cousin. So out of 5C4 and then 4C2, neither we want the senior cousin nor we want the junior cousin. And how did I know that? Because it says at most one. ज्यादा से ज्यादा एक cousin होना चाहिए. ऐसा भी possible है कि एक भी cousin नहीं हो.
Okay. It's coming to 30.
30.
Yeah.
Okay, so that makes a total of 110.
Yeah.
Okay, now you can try this.
Okay.
These are the answers for your reference. Let me know
Okay,
if
I'm
there is
just
any.
in the last part.
Yeah, okay.
So in the last part of B, we're gonna make cases, right?
Just a second. Let me read the question. Tickets for a concert are given out randomly to a class containing 20 students. There are 12 boys and 8 girls in a class. Find the number of different ways in which all the boys get tickets. Acha, no student is given more than one ticket. There are 15 tickets. So find the number of ways in which this can be done. Are you done with the first part?
Yeah, I'm done with that.
Okay. So this was simply 20C15.
Yeah.
There are 12 boys and 8 girls in the class. Find the number of different ways in which 10 boys and 5 girls get a ticket. So out of 12, choose 5, and out of 8, choose 5.
Yeah.
12C10 into 8C5.
Yeah.
Then all the boys get ticket. All the boys get ticket. So that would mean that out of 12, you're going to choose 12. And out of 8, you're going to choose the remaining 3 girls because there are 15 tickets. So what's 8C3? 56. 12C12 is 1.
Oh,
Okay.
yeah. Sir, in the last part, I was getting 336.
In part D
Yeah,
or part C?
pardon.
Part D. All other parts are the same as mine.
Yeah, I'm getting the same answers in those.
Okay. So there are six-digit numbers are to be formed using 3, 4, 5, 6, 7, and 9. Each digit must only be used once. Find how many six-digit numbers are even and greater than 5,000. Oh, sorry, 500,000. 1, 2, 3, 4, 5, 6. Six-digit number, and the numbers are chosen from 3, 4, 5, 6, 7, 9, and they need to be an even number.
Yeah.
So for an even number, it can either end up with 4 or a 6.
Yeah.
If it ends at 4, then I don't have any 4 left, and it needs to be greater than 500,000. So it can start with 1, 5, 6, 7, or 9.
Yeah.
So 1, 2, 3, 4. Four options for the first place.
Yeah.
Let's say I place in 5. So out of 1, 2, 3, 4, I'm gonna arrange all the four digits.
Yeah.
Now for the second case, one option for the 6, for 6 being at the end. If 6 is selected at the end, 6 is gone, then I have three options for the first. Let's say I place in
Yeah.
7, and then out of the remaining 4, I can choose and arrange 4. So
Yeah.
4p4 is 24, and 4p4, oh sorry, 4p4 into 4 is 96, and 4p4 into 3 is 72. 72 plus 96 is 168.
Okay.
Should I move on?
Sir, in
Yeah.
the for the even part, wouldn't it be 2p1 since there's still two options if you choose one?
Okay. The reason I've made cases is because if I would have taken 2p1 and not listed down this step, so there is a difference between the options for the first digit when 4 was chosen as an even number at the end. The options
Yeah.
were 4 for the first position, and if I select 6, then the options is going to be 3. That's why I cannot just take 1 and times it by 2. I cannot just write 2p1. It is going to give me
Oh.
the wrong answer then.
Oh, okay.
Okay.
Sir, in this one I'm confused. Will it be combination or permutation?
Which part?
I did permutation for all parts in this.
For 5 part A part 1,
I did it for all parts, so the A part 2 and then B is coming wrong.
A part 2 and B is fine. Okay. It is going to be permutation because they have used the word arranged. So answer for the second, we find the number of different ways books can be arranged if the 5 books about Europe are kept together. So there are 8 different books on travel, 5 about Europe, and 3 about Africa. You want the 5 books about Europe to be kept together. So in total, how many books are there?
In total, there of Europe or of total?
Total.
Oh, in total 8.
One, 2, 3, 4, 5, 6, 7, 8. The 5 are about Europe. So these books needs to be kept together. So how many bundles are there? Like the if I group all the 5 Europe books
Yeah.
into one single block, there are actually 4 blocks which needs to be arranged in 4 factorial. And then the 5 Europe books can arrange themselves in 5 factorial ways.
Sir, can you explain that again?
Yeah. So basically, if I want all the Europe books on the shelf to be kept together,
Yeah.
I I'll just bundle them up. I'll just treat it as a single block, because wherever I shuffle it, then these 5 books are gonna stay the same.
Okay.
Okay, so in total there are 4 blocks now.
Oh.
3 separate individual blocks for the Africa books
Hmm.
and one for the Europe books. So there are 4. I'm going to treat them as 4 different objects, which can be arranged themselves in 4 factorial ways, and then 5 factorial for the 5 Europe books.
Oh, okay. So then would it be multiplied into 3 again? 3 factorial.
No, because I have already arranged the African books, Africa books. These
Oh.
are Africa books.
Oh, okay. Sir, are you saying something? I can't hear you.
No, I wasn't saying anything. Are you done with these parts? Is
Uh,
answer to 5 part B coming correct?
One sec. No, for B, I was also getting it wrong.
Okay, so 3 DVDs and 2 videotapes are to be selected from a collection of 7 DVDs and 5 videotapes. Calculate the number of different selections. So this is a question on combination that can be made.
Okay.
So for this, it is going to be 7C3 into 5C2.
Oh, 350. Yeah.
Okay.
Yeah.
Yeah. Try one more question.
Sir, I'm done.
Done?
Yeah.
So what is the answer to the first part?
In the first one, I got 84.
Okay, that's correct. Second one?
126.
For the second one, I'm getting 15120.
Okay.
And for the last one, it's 240.
240. Yeah.
So let's do this part over here. Jean has 5 flagpoles in a row. She puts one of her 9 flagpoles on each flagpole. Calculate the number of different 5 flag arrangements she can make. So there are 5 flagpoles in a row, but she has 9 flags, and it's a question on arrangement. So 9c5 into 5 factorial. You forgot to multiply it by 5 factorial?
Then why do we multiply by 5 factorial?
It's same as saying 9p5.
Oh, okay.
It's a question on arrangement.
Okay.
Okay?
Yeah.
All right. Now, what you can do is you can take, yeah, we are done almost. You can take this question as a homework.
Okay. I've taken a picture.
Just a second. I'm just writing down the answers so that you have the answers with you as well.
Okay.
Okay. Now you can take the screenshot and try this. In the next class, we can start differentiation, inshallah. Also, on Google Classroom, the past paper worksheets for permutation combinations are uploaded. So now you
Okay.
can try them out. Okay.
Okay.
Thank you. Allah Hafiz.
All right. Thank you, sir. Love